Hello everyone, welcome back to the channel. Today we are diving with the topic that is what is customer segmentation. I have picked up the data set that is an online retail store data set. This data set is perfect for the customer segmentation. You don't need to worry right now about it like what is customer segmentation because I am going to explain you in a very easy way. If you are a beginner, this video is perfect for you. And even if you are a professional, it will help you to brush up your skills too. If you are preparing for the interview and you are looking for the easy and the quick definition, then this, like when you go through this practically the project, this is going to solve your many problems. So stay with me till the end of the video. Keep watching, keep patience with Science Data Science, and let me open my whiteboard because I'm going to give you the blueprint, what steps we are going to follow in our practical notebook before jumping onto the practical notebook actually. Okay. So let me open the whiteboard. All right. Okay. As I told you, we are going to use the online retail store data set and we are going to work on the customer segmentation project. If you are a beginner, first you need to understand under what type of machine learning this project come up. Okay. If you don't know what is machine learning, then you can watch my playlist. But I am going to explain you about the type of machine learning. So there is a two types, supervised machine learning and unsupervised. Okay. We are going to work on this today. Okay. I will give you the very brief definition about the supervised. If you are interested to learn in a detail, you can check out my playlist. So let's say this is the data set. Okay. This data set contains the number of rooms and price of the house. Okay. And your stakeholder is asking you to predict the price of the house based on the given number of rooms. Okay. So he has provided you this data set. So this is called target variable actually. Target feature or variable, whatever you want to say with labeled, okay, with label. You know the target label price and it is given. So that is called supervised machine learning, okay, in which you know the answer and you want to predict it based on, you train the model based on that and then it will help you to predict the value in future, okay. But in case of unsupervised, let's say your stakeholder has a business to sell the online images only about the flowers, okay. So he has provided you the data set. So let's take this one. This is ID, this is name, this is color, this is shape, okay. And here the different type of the flowers name, lily, rose, lotus, okay. And this is ID and there are some values, okay. So here your stakeholder is asking you, can you bring out some like the hidden patterns, structures, or can you group based on the different flowers, like and tell me which customer is buying which picture most of the time, either whether they buy the buying the lily flower picture or rose picture, and how frequently they are buying and how much total money they have spent, okay. But he is not asking you to do any prediction, right? So there is a no target variable actually. We are just what we are doing, we are just grouping the data based on the given features. So in this, what you will do in unsupervised, there is a no target, okay, no label is given. You will just try to find the patterns, groups, or you can say structures, okay, in the given data. So what you will do, you will make a three group here because you want to separate out. This is, let's say you made the one group based on the color, shape, right? There might be other features too. So you divide all points into this one, lily, and one group you made for rose, and one group you made for lotus. Okay. And this is also called the segmentation groups. Okay, this is you do in unsupervised. Okay, so this was the just like the definition. If you want to go with the real time example, first example for unsupervised is customer segmentation, which you are going to learn today. You don't need to worry about right now what is customer segmentation. I am going to explain you. The second, you can apply the strategy which we are going to apply today. You can also apply it on market basket analysis. Okay. The third is anomaly detection and so on. So there are a lot of examples, but I am giving you the most common example. Okay. So if you want, you can take the screenshot of this one. I hope you like understand what is the definition of your unsupervised and supervised. Okay. Now we will move ahead for the today. I have told you you are going to work with the customer segmentation today. Okay. Customer segmentation. So first I will make you the like understand first I will make you understand what is customer segmentation. Actually, the customer segmentation is the process of dividing customers into groups based on the similar behaviors or characteristics. Okay. So let's say what are those? The first is purchase frequency. Okay. So we can draw the here diagram, sorry, table too. Okay. So let's say you have this data set. So here is the customer ID, total spent. Okay. So I'm going to write here total spent. Okay. And this is invoice. So I'm just considering this feature, right? So there is a 1, 2, 3, 4, 1. Okay. So the first customer has spent $200 here. Okay. And it's this is his invoice, and he has again like spent the money again. So let's say 300. Okay. So this is another user who spent the $150 and so on. And this is the invoice date. It will also help you to tell how many transactions he has done and how frequently he has doing the like the shopping, because on invoice you will issue the date too, right? Might be he is purchasing the product from the online store. Which data set we are going to use today? We are going to use today the data set online retail store from different country. Okay. Two. So it will tell you right? Everything. So now in this, your stakeholder is asking you to prepare the customer segmentation based on their purchase frequency. How many times they have. The first customer has bought, let's say on Monday. I'm just assuming the name, it will be date actually, okay? He again bought the product on Friday. So this is a frequency, how many times he is buying, okay? The second point is retain spending habits. Okay. The second point is spending habits. Okay. So in this spending habits means how much money he is spending, right? Like maybe he is buying the products between the range of $50 to $60, maybe to $50 to $500, or maybe $1,000 to $2,000. Okay. So this is another behavior of the customer. The next is the behavior of the customer is recency of purchase. So this is a total, like the how many purchase he has done till today. Like if you are interested to know what the customer ID one has purchased till today, till this date, that is called recency of purchase. So these are the different like the behavior. Based on that, we will do the customer segmentation actually. Okay, so you will divide it into the groups. Let's say you have divided the 3 customers. You divided the from today we are going to divide into label into the customers. Label it one with the high valuable customer. Okay, who is doing the purchasing too much. So you will make a one group and you will cluster it with the one. Okay, this is the customer who is doing many purchase and your stakeholder is getting many benefit from them, right? Revenue is high just because of them. And the second is you might be like a cap it average customers who like do the things but on an average, right? The third is risk customer. Okay, might be they don't like the product, so they bought it two time and they return it one time, something like that. Okay, so you are going to, if you have this kind of the data set, you are going to divide these customers list based on their behavior into the groups, as I have told you this one. Okay, so this is you are going to implement it today using Python, and this is called customer segmentation. Okay, and what it does, why we do it, this is very very popular topic because the this is a very popular because you have seen many e-commerce platform, online store, basket, like the you place the food order, right? You do the grocery shopping. So this is a very hot market, and it relate to your domain, the marketing and finance. Okay. And second thing is it helps the business. What kind of the business it will help? To personalize marketing, right? If you are working as a marketing analyst, this is going to be very beneficial for you. And the second is retain valuable customers, right? If you think many customers, average customers, you want to make them the valuable customers, you might provide them the offers based on their behavior, right? And then the third is improve the sales strategy. Improve sale strategy. Okay, so this is very important. That's why you work on this data set. Okay, and this is a real-time example. If you still have a question, just drop a comment. If you are working on any customer segmentation data set, just drop a comment. I would really appreciate you. Okay, and now I will clear this one. And now here I will tell you what kind of the algorithms come under for this one. Like this is an unsupervised machine learning. There is a no target. So these are the common algorithm we use for this one. This is first one is your clustering, which we are going to apply today. That is k-means. Okay. And the second very common DB scan. You can also use that. There is a hierarchical. Okay, so these are the most common one. And the second one is some like the other one is your for unsupervised association rules. Okay, and the third one is dimensionality reduction. Dimensionality reduction is very popular algorithm, PCA. You can apply this algorithm when you have the many features, maybe 15, 10 or more than that, 30, 50, 100, then this will come up. Okay, definitely I will make a video on the PCA too. Okay, and there is a one more that is called TSNE. Okay, so these are just for your knowledge. We are going to work with this today. Okay, now we will clear this one. This is now your next step is key points you should keep in your mind when you are using the unsupervised machine learning. Number one, there is a no target. Okay, keep in your mind. If you are a beginner, this is just for you. There is a no target in unsupervised. Okay, second thing. Here the feature selection is critical actually. This is the most important step. Okay, because it is going to affect your result. There is a no target. We are not going to check any relationship, right? So it's a little bit tough. Feature selection. It's a critical step. Okay. The third is here scaling matters. Otherwise, your model is going to be biased. Okay. So you need to scale the data. And for the like the evaluation, you are not going to use here accuracy method. You are not going to use any classification or regression matrices. It has its own like the evaluation method that is called, if you we are going to work with the today clustering. So these are the evaluation method for customer segmentation. Elbow, and the next one is your silhouette score. Okay. And the next one is if you have the domain knowledge. Okay. So this is you are going to like you should keep in your mind. These are the points. Okay. And now we will move ahead with the next point, which is very important. So I want to make you understand this one first. I am going to use today RFM for customer segmentation. Okay. It is stands for recency, which I have explained to you in the customer segmentation, right? Frequency and monetary. Okay. So this is we are going to apply. This is called feature engineering method actually. Okay. So what we will do, we will extract the RFM from over each customer. Let's say again, we can draw this table here. If you are going to understand this very clearly, then the practical notebook will be very easy for you. Let's say this is customer ID. This is total spent. This is invoice date. Okay. So here 1, 2, 3, 4, 5. 200, 300, 50, 100, 150. And there are some dates. Okay. So now in this, using this RPM, what I will do, I will first like find out recency, how frequently or till today, not frequently, till today, how many purchases done by each customer. Okay, by each customer. Like if a customer ID 1 has done the till today, how many purchase based on their invoice? Maybe it has done the 10 purchase. Customer 2 has done the 20 purchase and so on. This is called recency. Okay. And what is frequency? How frequently? Okay. Maybe the first customer used to buy the products daily. Okay. So this is, I will say, 7 days, right? So 7 days, like we will count it actually. We will do the sum of this. Okay. I will show you today. And the second customer is frequently by, let's say, bi-weekly. This is, I'm just making you understand what is the meaning of frequency. Okay. As a layman, I will show you practically too. Now the third is monetary. This is total spend. Let's say the customer ID 1 spent the total $400 in a month or maybe in a day, and the second customer has bought the 600. So this is we are going to do. So you can assume now if you are a businessman or you are a stakeholder, these all values are very important for you. And your data scientist is going to like group the customers based on their this behavior. Okay. Here it will say if the customers is doing the purchase like the between 10 to 20, then it should be in the group 1. If they are doing the purchase between the 50 to 60, they are in the group 2. If they are doing the purchase between 200 to 150, they are going to in this. It can be in opposite way. One is the highest valuable customer. This is average or this is low. Okay. I'm just giving you the example. Okay. So you need to understand this very clearly. This is very important. This will give you the very clear clusters and the results to the stakeholder. It will be very easy for you to make understand about the customer segmentation to your stakeholder. Okay. Okay. So now we are moving ahead here today, the process we are going to follow. Okay. So the first we will load the data set. Okay. And then we will do visualization plus EDA. The basic one, checking missing value, outlier, sorry, duplicates. Okay. And the uniqueness and do that. And then third, we are going to do the RFM feature engineering. Okay, and I am going to apply the two models here with the RFM because I wanted to show you the difference, and then without RFM. Okay, and then we will do some visualization here. And after doing this, we are going to fourth step, we are going to do evaluation. Okay, in the evaluation, we are going to use two methods, elbow and silhouette. Okay, so this is the process you are going to look in the practical notebook today. This is going, I'm not going to apply today PCA because we don't have too much features. Okay, but this is going to be the perfect project for you today. Okay, so let me now open the my notebook and share it, and we will close this one here, and here we will share the entire screen. Here you go. Okay, so this is the notebook. I'm going to use the Google Colab today. Okay, if you are using the your Jupyter notebook, then you can keep your data set at the same place. If you are keeping it in a different directory, then you can set the path. Okay, and here this is the link of your data set. I have downloaded the data set from here. This is an online retail. This online retail data set contains all transactions occurring for UK based and registered no store online retail between the year 2019, sorry, 9 to 2011. Okay, the company mainly sells a unique all occasion gift wear. Many customers of the company are wholesalers. Okay, so we are going to do the analysis of this one today. So you can apply the classification too if you are interested in that, but I am going to use it for clustering. This data set is best for clustering actually. Okay, and then we will come here. So here I have given the heading, and now look at this one. Here we are importing the libraries, which is important. Okay. Now, before moving ahead, I will tell you, I have already uploaded the data set here. Let me run all cells again. So we don't find any error. Let me check it again. Because when the file is opened since long time in Google Colab, it get disconnected. Okay. So we need to connect it again. So the data set is big, so it is taking a little bit time. So here these are importing the libraries. The pandas, NumPy is for your data manipulation. Matplot, Seaborn is for your data visualization. This I have imported because I don't want to show the extra warning sometimes come up in with the output. It disturbs me lot. So I have removed it. Okay. So you can also import this library and then normalize and cluster using k-means. So we are going to use k-means. As I told you, we are going to work with this algorithm. Pipeline, standard scalar, k-means, column transformer. Column transformer pipeline I am using to build my, like preparing the data for the model. And then we will implement it. Okay. Okay. So here this is, the file is in the form of XLS. So what we will do, we will read the file using read underscore XL, not CSV. Okay, and then I am making the copy of my original data set because I don't want to touch my original data set. I will work on the copy one. Okay, and then we will use a head method here. In the head method, you can see this is a invoice number, this is a stock code. Okay, description, we have the quantity, right? Invoice date, price, customer ID, and country. So these are the features you have. Okay. Now, keep in your mind whenever you are working with the customer segmentation, when you are like do the analysis for the clustering, your ID is going to give you the very good results. We cannot delete the customer ID from now. Although in my previous all projects in the supervised machine learning, we drop it because there was the no use. But here it is going to play a big role, right? Because why? Because you are interested to know the behavior of each customer. If you delete the customer ID, how would you come to know which customer, right? How would you group them, right? So this is important. This is the very basic point I'm telling you when you are doing the customer segmentation analysis, okay, and model. And here, this is a quantity. Invoice date is very important because this is going to help you to tell the frequency of purchasing, right? How many times the customer is buying the product. Interval, or maybe daily, weekly, bi-weekly, monthly, 2 months, 1 month, right? Price, what is the range of the money they are spending on the product. Description, this is like what product they are buying. This is a stock code, and this is the invoice, and this is the country. Okay. Now we will use the info method to look for the different like the data type, how many records we have. We have here 5,25,461 records. It's a big, right? And you have the 8 columns. So this is the object, the first 3 columns, invoice, this one, and invoice date is coming in its correct form. If it is not, you need to convert it into date and time using the pandas method. Okay. If you don't know how to do that, you can watch my playlist. I have recently uploaded the time series actually data project. Okay. And then you have the price and customer ID. Okay. Here we are using the describe method to just check the statistics of your each feature. So here it is showing the quantity this much, standard deviation is this, mean value is this, maximum value is this, right? It is very far away from your actual value if we see, right? So there are outliers, okay? And then here is the invoice date, although you can try, but it is not too useful. Price one and customer ID. The statistics help, this describe method will help you to like check about the your outliers too, because you can see the values which is very far away from your mean value. Okay, look at this in the price too, very far away, right? Its minimum value is showing in the negative because there are some customers who might return the product and we return them the money. Okay, so that's why it is showing in this form. And then we will check the missing value. This is our basic part of the EDA. Okay, if you are a beginner, these are the basic steps you have to perform. Okay, even if it is a supervised machine learning, you are going to perform all these steps. Okay. And then here we will check the duplicate. So there are a 6771 duplicate. I don't need that, so I will drop them. Okay. Null value. So here the null value, it is showing all 0, although there were the null value because I have, okay, here you go. So here you have the null value. Okay. In the description, this much, and customer ID is this one. Now, the question mark is sometimes students think a lot. If there is a missing value here, how I am going to handle it? You will see the customer ID is of a object flow type. If you are at a beginner level, you don't have experience to handle the missing value, then this tip is for you. Customer ID is the value something we can't refill it actually. Okay. Even it's a lot of like we will say count, it's a big data. We are going to lose the big data, but we have to drop it because this is not something which you can fill, right? I cannot take the mean of this thing. It's a unique, right? It's a unique ID. So whenever you have in your data set these kind of the situation, you can just drop them. Okay. And then if you really want to learn more about how to handle the missing value, then you can watch my playlist. It's very in detail. Okay. And then when I drop the customer ID, which were the missing, and checking the duplicate, so you can check the description is also okay. So this means some data where the customer ID is missing, their description was also missing. So there was the no use of that records. So it's gone. Our data is clean now. Okay. Okay. Now, to Here, first of all, we will find out the total price because we are interested, right? Total price means like quantity multiplied by price, right? Sometime a customer bought a same product 10 times, right? So you are interested to know the total price, right? How many money they have spent on the single product. So that's why we are calculating it here using our pandas method. This is very simple. The multiplication here operator. Okay. And then we are doing the visualization here. This is very easy. We are just showing the top countries. Okay. Top countries by the unique customer, like the how many customers have in the countries, because we have the data set from Germany, France, and Spain, and other countries too. But we are just taking the look, although they have mentioned mainly they have the data in the UK, but you can visualize it. So it is showing the 4,000 count of the customers from the UK. And there are a few customers below 500 in Germany, France, and Spain, and Netherlands too. Okay, so this is going to give you the clear picture. This is the first visualization you can do, okay, for your customer segmentation. And then we will look for the visualization top products. Okay, so in this, what we will do, we will first check the description unique value, like what product they have, like a bought, right? Different product, but might be the same product bought many times by the different customer. So we need to do the here value count to find the unique values, okay, of the description. And then we are just plotting the bar plot. Now look at this. So the white hanging heart tea light holder is bought most of the time, right? These are above 3,000 quantity. It's very high, and this graph is very useful for your stakeholder because they can now look at this which product is selling most of the time, right? They can add more combination with this product. So they, if the customer is buying this product, they can buy the other product too. So this is called marketing strategy, right? This is a way how they come to know. The big store, the Walmart store, superstore, big basket, right? Your Flipkart, Amazon. This is they how they come to know. Okay. So this is a very useful top selling product. Now we will do the feature engineering. Okay. Before doing the feature engineering, first we will apply the model without this tool. Okay. I have already explained you the RFM analysis. That is recency, how recently the customer purchased. Frequency, how often they purchase. Maybe you are buying the one toy or color box thrice in a week. So this is a frequency, right? And monetary, how much total money you have spent on all products. Okay. So we are interested in this. Now you can see RFM is very useful. Using these three strategies, it is very clear you can find out the customer and you can group them into the different groups, right? Before applying this, first let's see without RFM how your model work. Okay. The most important and the big difference between supervised and unsupervised is we don't split the data in unsupervised because there is a no target actually. Okay. This is for you. If you are a beginner, this is another difference. Okay. In supervised, we split the data and then we will implement the model. But in unsupervised, we don't need that. Okay. And now we will say here group by the customer ID and calculate the other behavioral features. You might thinking why we are doing this? Because your same customer may bought the many products, right? You need a total sum of them. So that's why you need to do the group by. So you will do the group by customer and you will take the aggregation of the invoice, quantity, aggregation means and unique. We will set the pattern of this one. This is inbuilt method actually. Okay. Sorry, any unique means it will pick up the unique date of the invoice. Based on that, it will do the sum of quantity, total price, and it will take the average price, take the mean of that one. Okay, so we reset the index and we will prepare this data set, and then we will set a new column because we need to give the, we are preparing the here features too. Okay, again I will say in unsupervised selection of the feature is very important. Okay, did you notice I did not use the feature here description? This one I did not use the here feature stock code. Okay, we are using only the invoice, we are using here the price, customer ID, and total price. Okay, because this is not going to contribute. We know it's a UK country, most of the data is there. We are going to grouping them. So there is a no use, there is a no use of stock code, because based on the stock code, we do no information is going to come out. And from the description, we don't need it right now because we are not going to perform any analysis on NLP based. So I'm dropping that. This is the reason I'm not using. That's why the selection of the features during the unsupervised is very critical, because it is going to affect the result of our model. Okay, so we have picked up this one, and then customer ID, num invoices, total quantity. I have keep the new name according to our this we have prepared, and then we will normalize. I showed you the process on the whiteboard, right? So you need to standardize them, otherwise your model might become biased. And then we will scalar fit transform. Fit transform means it will fit and transform the data to the customer features and this one. Okay, and it is going to do that. Here we are using all your invoice, this one. It is going to find the quantity which is the unique, and other one. Okay, and then we will just take the number invoices and this one. And now what we are going to do that we are going to fit the k-means clustering on that. This is the most popular algorithm we use in unsupervised for the customer segmentation. Okay, it is very popular. And how it works? It works based on the clustering actually. The k means k nearest neighbor. I will explain you how it works. Okay, just give me 1 second. All right, so let me show you what is customer segmentation actually. Sorry, k-means. Okay, so I will draw. Look at this. How the k-means work. Let's say you have the few points. Okay, so this is the one. I will take the different colors actually. 3 points, this one. And some points are here. Okay. And there is a one a new point come up here. Okay. This is a new point. Now how the k-means work? K-means work means it will separate first your these like let's say let me make a one more green label to here. Okay. And here. Okay, so what the k-means do, it will first find the center point based on the given features of the your like the any data, like here is a customer, right? So based on the given features it will like find out which is close to each other. How? If you look at this invoice, quantity, total price, and price, what it will do? It will divide it into the clustering. If I am giving the 4 clusters, so it is going to show me the 4 groups different, and 4 different groups divided based on the behavior. Let's say there is a customer one. It is buying bi-weekly, right? The frequency is 2. So it is going to separate them in a one group. The customers who is buying the products 2 times a week, they will put it into the one group. So you can assume this is a group. Okay. And the customer who is buying 4 times in a week, they will put it into this group. Okay, and k means will separate them like this. It will find out the center point and then keep the all data points close to this one and make them a one group of that. It has the centroid point. Okay. Same with this one. It will find the mean of this one center point, and whatever points are coming close to this one, it will be here. But you can see there is a one more data point. Now it's how the model will decide. It will go to this group or this group, right? So it will try to find out the distance between this mean to this data point, this distance to this, which is less. It is going to merge this data point into that group. So if we find this is close to this one, so it is going to, the blue dot is going to be grouped into the red part. Okay, so this is called k-means clustering. This is just the overview as a layman. If you want to understand it in a detail, you can watch my playlist. Okay, and then this number of clusters you can pick up according to your choice randomly first. Okay, I have picked up the 4. Random state is equals to 42, and then we will say customer feature clusters, which we have prepared here. Then we will fit and predict the access scaled data, which we have prepared here after transformation. Here we are not going to do the transform because we have already done. Okay, here we are just predicting. Now we are plotting the pair plot to show the different clusters. Okay, your VATs, NumVoice, which features you have like created here, palette tab 10. You can make changes the colors if you want. Then subtitle, this is the title of your each subplot, and then plot.show. Now look at the result. 0, 1, 2, 3. Okay. So in this, if you look at the number of invoices, okay. So the average price. So here we can consider the 0 cluster belongs to the high valuable customers. Okay. We can assume that because the average price, they are spending the money, average price around between the 5,000 to 10,000. So you can label it valuable customer. This is you need to do actually. Okay, and then you can see the clusters for the 3. This is very less, right? At some point total spend money, here you can see below your this price, and there are some like a total quantity, there are high, and your number of invoices is showing here, total quantity is showing here, right? So this is a average. Okay, and then if you look at the 2, here 2 cluster, no result, right? It's very less, but there is a some person who is spending about 10,000 too. Okay, so it will divide the groups now in different, like divide the data, your customers' behavior based on these clusters. But I did not apply any RFM. I'm just directly applying the k-means on that. So this is a result for it, but it is not too clear, right? If I show this, try to make a understand to my like the stakeholder, it's not a good result. Okay, so for that I just wanted to show you the like the difference, so that's why I'm showing highlighting this. So this is without RFM. Now we will apply the RFM. Okay, feature engineering. For that you need to import date and time as a DT, and then we will latest date for recency, because we want to calculate till today how many purchases done. Okay, so here we will find the invoice date maximum, the most recent one. PD dot time delta days is equals to 1. We are adding one extra day, right? So we can pull out the results from the day 1 from the current date, right? And then RFM ED underscore DF group by customer ID, same function we are using. We are applying the lambda method on the invoice. This is an anonymous function built in Python. We call it one-liner function too. And snapshot date. This is the date which you find maximum date. Let's say your maximum date purchase is done today, 5th or sorry, 1st of May, right? And then minus x dot maximum. What is x, your x maximum? This one, this will find the maximum date from the current date, and then we will be able to find out the how many days. Okay, and then here you would have the invoice and unique, and then total price sum. So we are considering these features and creating recency, frequency, monetary. So this is the way how you apply the RFM actually. Okay, here you only need to more focus on the recency, because frequency we have, we can do the total count, right? We can do the monetary total, but this is we need to find out till today, right? Frequency. So this is showing you the all. So I have printed the top 5 records. You have a lot of records. Okay. So now we have the RFM result for each customer. Okay. You can see 67. So this means till today he has done this much transactions. Okay. And total frequency he has the buying 15, right? And this is minus 51 because might be he has returned some like the item and we have returned the money. Okay. Here we are just plotting the subplots to show you the distribution. This one, look at this recency. So recency means like till today, how many like the transactions he has, most data records we have between 0 to 50. We have above 352, but most one is discount is high, right? So transactions till today for each customer between the ranges of 0 to 50. And if you look at the for the frequency distribution, the purchasing like the frequency most frequently, right? So this is also between this one. And then monetary distribution, total spend money, this is between 0 to 50. We can say 0 to 10,000, right? So this is going the this graph you can also you can rename it with the labels of which your stakeholder can understand. Instead of monetary distribution, you can say total money spent by the customer, right? Frequency distribution, you can say that how many times the customer is buying, right? Like the how many times, right? Resensing is still today how many transaction he has done. Okay. Now, this is just for your understanding. We are plotting the here the heat map. What you need to do, we are just calculating the RFM scores. Okay, this is for your recency score, this is for your frequency score, and this is for your monetary scores. How you can do that? You can use a pandas method q cut. It will cut it into the bins because you can see here there are so many ranges, right? How would you organize it? I'm not going to label it up to 350, right? So we need to divide it. So we will say Q cut. It will make the bins and label them with the 4, 3, 2, 1. You can name it with the valuable customer, risk customer, average customer, or others like this. Okay. But this is a way how you can just cut them. And then same for the frequency, rank. We are using the rank method first, right? Because we want to keep it at the top. So this is the like the 4 again, 1, 2, 3. So which is at the first rank, their frequency is very high of buying the product. M score monetary, here we are using this Q cut method again and labeling with the 1, 2, 3, 4. This is important actually. Why maybe you are thinking why we are doing this. We are calculating the RPM because we want to implement using this result for our model. That's why you need to fetch out, because now you are analyzing the behavior of each customer, how much money total is spent by each customer. This is the first behavior by the M score monetary total, like your F score frequency score, how many time he is buying the like your product, how frequently, right? So if I show you here again, look at this. I have written the definition, how often they purchase, right? Recency, how recently a customer purchased. Okay, like the till today. Okay, recently. If maybe that customer, you have a one customer who has bought a 3 months ago, like the many product, but recently he did not buy any product. So you can group those kind of the customers in the different segmentation. Okay, so that's why this is important. Okay, and then we have here, all right. So here, now we will prepare this. Okay, so you have prepared the each customer's three behavior. which is very important for the stakeholder, right? It is going to give them the very clear picture. So I have combined it into the segment 2 because I wanted to plot this one. I wanted to draw the graph too. I have drawn that graph. That will make more sense for your stakeholder and for you too. This is RFM segment. This is R score. We will convert it into string type, RF score, and then convert into this and this one. So these are the three segment. Okay. So I have divided it into the segment actually. Okay. So this is it will become now number. If you are, how it will become the number, I will tell you. Let me open the annotate. So here we go. Okay. So now your R score first label. Let's say your some customers lie under fourth label. Okay. And their F score, how many frequency? 1. So this will become 1. Okay. And then M score 1. So this is your one group, one segment. Okay. And this is with this, we are going to do this one. Okay. And but what we are going to do here, we are going to do the sum of R score, F score, M score, total score of the your RFM. This means 4 plus 1 plus 6. So the total score for this first group was 6. Okay, so this is the difference. This is a segment. This is the sum of your all scores. You have like a fetch or calculated using RFM analysis. This is very important information which I am sharing with you right now. Just listen it carefully. What we have done. Let me clear this drawing first. Okay. So what was that? You have the three behavior, right? So R, F, M. R is your recency. Till today, the customer how many purchases has done. Maybe they have bought previously the so many products, but recently they didn't buy any product. So that behavior is different, right? From the customers who is continuously buying till today. So we need to separate them from this group, right? We will keep them onto this group. This is the group, right? And then you have done frequency, right? This one. How many time? Total frequency. So you were labeling them into the 4 groups. Maybe you are thinking why I am dividing into the 4 groups. You can divide it into 3 groups. This is your choice. Valuable customer, average customer, or other customer. Okay, choice is your. So I have divided into 4 parts like valuable customer, average customer, risk customer, or other customer, which does not belong to any other customer behavior, who is not buying frequently, who is not doing the habit transaction, who is not buying the product till today. So they don't lie out of any category of this one. So that's why I will keep them in the other category. Okay. So this is choice is your. Whatever your stakeholder requirement is, you can work according to that. Okay. And then we are doing combining into segment. Here you are not doing nothing new. You're just combining all labels. Let's say you have the, I will again make it. So let's make this one. Okay. So I will take an example of customer 1. Okay. So customer 1, R score. Till today, he is buying many product. Okay. So I will name it with the 1. Okay, I'm just explaining this line, what is segment. And then his F score is very high, it is also 1. His M score is very high, 1. So this, for the customer 1, it will become this value as a segment. But for this one RFM score, it will become 3 because we will do the addition of all these 3. That's it. Okay, this is what we are doing here. Okay, and now here we do. Then we are drawing the here your heat map. Now look at this. This is a frequency score. This is a recency score. So the first one has a we are interested in this, right? The customer who are valuable or this one, right? So we can send them the promotions. We can send them the offers, so they don't leave, right? So this heat map is showing you the frequency score. If 542, their recency score is also high. Okay, and if it is a frequency you are here you are at a first 266, 214, it's very high. Okay, but at 4 it has decreased, right? So this is the just to show you the heat map, the relationship between it. Okay, just for your understanding. Now I have just write this code to check my different like the RFM score labeling. And now what I'm going to do, I'm going to convert, because I have a labeling starting from minimum 3, it is going up to 12. If you want, you can give the these label name too if you want, but I have converted it into the groups, ranges. Okay, like if the customer is a RFM score is lie between the 0 to 4, then it should say at a risk. If it lie the score between the 4 to 6, it should say need attention, so we can send them the offer. If it is lie between 6 to 8, potential loyal. And then if 8 to 10, he is loyal, so he is continuously doing the shopping. If the range is between 10 to 12, he is a champion. Okay, so I'm labeling it like this. If you want, you can label it according to your understanding. It's a not fixed one. Okay, then I'm just drawing the graph, so it will make more sense to you. Look at this. So how many number of customers need our attention? You need a 800 above customers. So this graph is very, very useful for your stakeholder. They can clearly, immediately understand what is the count, what is at a risk, what they can do. Okay, so this is giving this thing. So you don't need to tell them the labeling or everything. This is easy. That's why I showed you how you can label them. Okay, this is very easy for the non-technical stakeholder to understand it. Okay, and now we will calculate the total price. We have already calculated above, but we are applying the here your model onto the RFM. Okay, so where is the RFM? This is the one. This is a RFM column. Okay, we will group by this one, snapshot, this one, columns, recency, frequency, and monetary. And then we are just saying, here I am filter out actually the top 1% outliers. This is very important in clustering too. Because if I'm going to keep the outliers, my model might be go to biased. Okay, this is very important because we are going to do the grouping actually, right? If my one customer's purchase is normal average customer purchasing frequency is between 100 to 350, but I have a one or three, four customers whose purchasing power is 800, then it is not going to be good for me, right? So it's a better, the good habit is just to remove them. Okay, because my model will get confused how it will give the weightage. Maybe it will like give the weightage to more to the 800 one, and it will not get trained to separate the groups which is between the range of frequency your 1 to 350. So this is important. Okay, so we are setting the range monetary, total spent money less than this one, quantile 0.99, only 1% out of 100. Okay, and then we will create the pipeline. This is our features which we have created here. Okay, your recency, frequency, and monetary. I am applying the same formula which we have applied above, direct to our data set. Okay, here we are applying with over this one, right? We are calculating the here recency, and then we are calculating here frequency, and then we are calculating here monetary. So three features we need. Previously, you were using the direct feature of your data. Here you are using the features according to your RFM actually. Okay, this is the difference. But formula is the same. And then we have removed the top 1% outlier. Here we are creating the pipeline and models. It's a very simple pipeline steps. We will scale them. It's very important to scale them. Again, the model will get biased otherwise. Preprocessor column transformer, we will pass the pipeline inside it. And then we are applying the k-means. Here again, I have taken the 4 number of clusters. You can take 2, you can start with 2, 3, 4, whatever. I have the label 4, so that's why I'm taking 4. Okay. And then pipeline to fit on the RFM filter data. And this is a pair plot result. See, it's too much big difference, right? it is able to like cluster your each group very clearly. Look at the difference. If we go above, look at this. It was not able to group them. You can see on the green, the blue and red were overridden. We are not able to see the green labels, right? It was not able to cluster them, grouping them properly. Okay, so that's why RFM is very, very useful. Okay, look at this now, how clear this is. Okay, it is also the like your pair plot where customers based on the RFM clustering. So 0 here, look at this, the blue is showing the pattern. You can again give the name according to your choice. Okay, who is the champion, who is the loyal, who is the potential loyalist, we can label them. Okay, and if you see, it is very, very like the grouping is very clear, right? Even you can see here it is overriding here some point the cluster 3 somewhere, but it is very clear. Okay, and now this was our goal, like to cluster, to separate them in the different groups. Okay, so now you can label them according to your choice. Okay, here the evaluation method. Now if you are not sure if you are using cluster is equals to 4, is it the good value or not, right? Because this is just that we start with the actually because we want to group it, we want to divide them into the group. So you should start minimum with the 2 value, right? Group can be 2, it can never be 1, right? Because we are separating them. So here if you're not sure 3 value is best, 4 value is best, then you can use to evaluate your unsupervised k-means or customer during customer segmentation. If you are applying the k-means algorithm, then you can use the elbow method or silhouette method. This is very popular. In this, you need to import here this one k-means. We have already imported the above elbow or silhouette at the top. So here we will just check the within cluster sum of the squares. Okay, what it will do, it will pick up the range from 1 to 11. What it will do, it will, we are setting the range of k cluster mean. Okay, starting from 1 and then 11, then it will just pick up the k value 1 1. It will pick up first 1, which there is no use of 1. Then it will pick up the 2, and then k means fit on that, and then append into this one, and then we will plot the graph here. Okay, so elbow method is very, very popular. Okay, whenever you see your this line of the elbow here, it is showing the elbow actually. Okay, whenever you see this one, it is tilted from here, that value is going to be best for your k means. This is the way how we look at it. You can set any range, you can set the range from 2 to 10, choice is yours. Okay, there is a no like a fixed rule, but here you can look at this. Using this you can evaluate the model to find the best k value for your clusters using the k means model algorithm for your this data set. Okay, and I am considering here 2. Otherwise there is another like your elbow 2 here. Okay, there is a third elbow. Okay, if you are not sure about elbow method, after that you can see it is going to be little bit consistent and going down. So I'm not going to use that one. So this means if I want to stop, I will stop it here, or might be I will use 3. Okay, but to cross check it, double check it, you can also evaluate using the another method, silhouette method, score method. Higher the score, good is the k value. Here again we will set the range. We can also make it 2 because it will not make sense with the 1. Okay, so we can do that. Here we need to rerun all. I think this is going to be disconnect again. So let it run. All right, so after running this one, it is showing us more clear, right? So here it is showing us 2, 3, 4, and this one. So if you look at this WCSS means inertia value of the elbow, okay? Sorry, I mentioned it, I didn't mention it earlier. So this is your inertia value. Okay. So low the inertia value, good is the value of your clusters for the K. Okay. In the, for the K means in the elbow method. Okay. On the y-axis, this is inertia. But if you look at the silhouette score, this is a silhouette score and this is a number of clusters. Higher the silhouette score, good is the K value. Okay. Now look at this. It is a higher, so it seems to be 2 is the best value. If we look at this, the first elbow here, it is becoming 3. Now what you can do? Your job is you can try to fit your model again with the cluster 2 and cluster 3. Okay, which is performing a good segmentation, good grouping, separating good. There is a no overriding. That is going to be your best value. Okay, and here we can again look at this. Okay, so I have fitted it with the clusters 2. Okay, so I have chosen the value 2 and this is the result. Okay, here it is little bit overriding in this case, right? The rest seems to be fine. Okay, if you want, you can try it with the 3 separately. Okay, we can try here too if you want. Let me fit it again. So here we go. Okay, so this is the 3. This is also seems to be okay. You can try it. Okay, so this was the all about your customer segmentation. If you still have a question, feel free to drop a comment. I would love to answer, and tell me which data set you are going to use for your like the customer segmentation. But this is what I will suggest. If you are a beginner and you are looking for the project for the customer segmentation, then try this project and try to understand in detail about the RFM. This is very important. Okay, many interview questions come up on this. Definitely in future I will make a videos on the interview questions too. But right now just learn about to try to build strong portfolio with these end-to-end machine learning projects. You can watch out my end-to-end machine learning project playlist. I have uploaded many videos on different real time and from the different domains data sets. Thank you so much for watching this video. See you again in the next video. Keep watching, keep learning with Science Data Science. Thank you.